Good afternoon, everybody. Welcome back to this session of the workshop. For this presentation, I will go through the notebook on downloading GeoMat data from Digital Earth Africa Sandbox using a shapefile from a region of interest. But prior to this presentation, I just want to make a recall. If you want to use the first presentation we did before the break was on Landsat, downloading Landsat data from Digital Earth Africa Sandbox using a shapefile from a region of interest. On that notebook, you can change the product Landsat 8_SR by using Sentinel data. So for the specification of the product, you go to the, you look at the product available in the image available in Digital Earth Africa platform, and you use the specification for it, and you run the notebook accordingly. Then, so we'll use the same procedure as we did for the Landsat imagery. And for this one now, we are going to use GeoMat. GeoMat is a product of Digital Earth Africa that give you or make available the geomedian image covering Africa and specifically your area of interest using the geomedian image. That is the combination of all the image available during a period of time during the year on a single image product. And for that now, you will not have those issue of period where you have cloud cover or not cloud cover. You have the geomedian for the year you can use for your study. So you can have a geomedian for the year 2020, you can have a geomedian for the year 2021, and so on and so forth. For the year you consider, the 12 months should be completed. If the 12 months are not completed, you cannot have the geomedian product. So we will import the packages that will be necessary for the work. They are the same for the previous notebook. You connect to the data cube using the DC equal this data cube dot data cube import data set. You define your area of interest. We are using the GeoMat. We want to have the GeoMat, download the GeoMat product. And we are still in this Boku area. So we use the same shapefile. And like we mentioned earlier, on your table of contents, where you have your notebook that are here with the orange icon, you have here the shapefile and the accompanying file that enable the display of the shapefile that are listed here. And you copy the name and the extension, the format of the shape, and you paste it here. You create a geopolygon and geodata frame of your area of interest, and you get the latitude and longitude of your geopolygon. When we have done that, you display the map through the X long range and the Y lat range. Our area of study appear here. I can use this to increase the minus or the plus to increase the zoom in or decrease the zoom. We created a query object where we define the X, the Y. We indicated the time, 2022. This 2025 will not appear because the 12 months have not been completed. So you will only have an image for this 2022. we define the resolution 2020, and the measurement also is indicated in red, green, and blue, and the output coordinate reference system is the EPSG 6933. We do not specify the minimum geodata because it is only the all good imagery that has been used and the median, geomedian of the image that has been produced. We put DC equal DC loads. The product is geomedian S2, Sentinel-2 annual. We mention here annual and we print the request. And that we have our XRA dot data set. We have the dimension here, which indicate the number of images available, that is 3. So it will be 0, 1, and 2. We have the time specification, is 2022, February, 2nd of July, 2022. And we have the data available, that is red, green, and blue. We define the coordinate system and we grid the mapping by using the spatial reference. We now display, we print the result, this DS result, and from that DS result, we will have the imagery that will be available for those 3 periods. So we will have here 25 elements. The index here is 3. We plot the result. We will display the result return data set using the RGB function. We put RGB, DS, the index, we selected the first image, and this is what it gives us as image. So when we do that, you see that this one is the image covering in the scene. Now we will come and we rasterize our shapefile to be able to clip this image. So when we rasterize the image, we use the mask as XR rasterized geopolygon underscore geodata frame, DS. We use the mask by defining DS equal DS dot where mask. We plot the mask using the same index, that is the first image. And we see now using our shapefile, it has been clipped and just cover the area of interest accordingly to the shapefile. Now we can export the band by using write koji, etc., red.tif. We export the multiple geotiff, one for each time slice of an X array. For I in range, length, ds.time, we will use the date of the satellite image to name the geotiff. We convert the time step into an xarray dot data array, and we write the geotiff. So we have all this as available as image. So it starts from 31st July 2022 up to 31st July 2024. So if we look at our result here, we will see that we have here the 31st July 2024, that is this last one, up to 31st July 2022. Which one is here? So all these are the result we obtain from these export multiple geotiff, one for each time slide of an array. And you will see that you have it on a monthly period up to 2024, and you have your geomat for the time covered. So the geomat cover your image on the time period for a month, and it will cover the whole year. Thank you very much for your attention. So those who are interested in a time series study covering a period of time, you can use the GeoMap to do your work. Thank you. À vous.
Okay, merci. Thank you. Mr. Asuma. Now, let's first have some questions. Let's take some questions. You can put them in the chat. I can see one question. Can we get the shape files? Ideally, it would have been good that you also use your own shape files later. But we make the one we use here available for you. Oh, okay, it's already there even. You can try it. After you have tried this one and it's worked, please, it is recommended that you apply to your own study area, which means you will need to generate another shapefiles, another set of data that you will use to run your own notebook to achieve your own purpose. Thank you. Do we have any other question? Can we take some questions? I can see Mr. Apurere Justina. Justina, how are you? I'm still I'm still a bit confused on how to run the kernel. All right. I will ask Mr. Suma. Somebody
Okay,
said
for the, I
the
will take
kernel, the running of the kernel.
for the, I will take the geomat as a demonstration
All
for
right.
how it's done.
Okay.
Okay, can we do that?
Yes, we can do it.
So like we mentioned, the notebook for this presentation has already been customized. But for other users, you have to customize the notebook to fit the purpose you want to achieve. I will go to kernel, and I said restart kernel and clear output of all cells. When I do that, I click on restart. The notebook will be erased. That is, you will not have any results. And from there, just a minute, because I think we have a connection issue for the platform to restart the notebook. But like I mentioned, we will have different cells where we have the scripts. So we upload the package, and when we upload the package, you click on the cell. And when you click on the cell, you come to this button, run this cell. And when you click on this, run this cell, it will execute the script. And you go to the next cell. And you will do the same until you complete all the cells. Let me go back to the PowerPoint presentation. Okay, so in this PowerPoint presentation, you have this is the first cell. So what you will do, you click on this cell, and you go and click run. Otherwise, you just click on the cell and press Shift Enter. The cell will be executed. And from there, you have loaded your package. You connect to the data cube. You do the same. You click on the cell, click run, or you do Shift Enter. And you do it for the subsequent cell up to the end. It is at this area here where you define your area of interest, your AOI, where you will now insert your shape file. Here you define your coordinate reference system. You display the map. It will be framed on the map background to enable you to ascertain if you are really covering your area of interest. You will create a reusable query where you will indicate the long range, that is the extent in longitude, and you indicate also the extent in latitude. You define the time period. It is 2022. We indicated here 2022 to 2025, knowing that 2025 has not been completed. So the system will run it from 2022 up to 2024. We indicate here the resolution of the image. The measurement here indicate the band we are interested to use. And here we have the coordinate reference system. This is the coordinate reference system used by the EPSG, that is the European Petroleum Group, Society Group. So it will give you this information by when you have loaded the product using the GeoMat S2. This is the Sentinel-2 annual, that is the annual product. You have them on monthly basis to cover the whole year. You display here the index equals 0, that is for the first image. And when you have your first image, it has given you here the period 31st July 2022. That is your first image. You mask your image to be able to extract your area of interest accordingly to your shapefile using your first image. We have now the export of single band and single time using GeoTIFF. But here we want to export all the bands or all the image GeoMat available during the period of 2022 up to 2024. And you run this one and it is executed. Thank you. If there are other information or clarification you need, you let us know and we follow it up. Thank you very much.